This quick little video is really an important video. I wanted to get in the lab here, and I wanted to show you a little bit about why significant figures are so important. As we look at weighing stuff, especially the more precise that we get, this is a triple beam balance. Once again, the triple beam. Many of you, I'm sure, have used a triple beam balance. But what we do, and we'll bring the camera up a little bit, we put what we want to be measured here on this one. We start out, we put them on 0. We what's called tare it, T-A-R-E. We get that to 0. But then let me move these back. So then we begin to try to get the weights to match up. So there's our 10-gram weight, 0, 100, 200. Okay, so now what I basically want to do here, I've got the 10 in the notch right there, and I want to get this to where it comes to this line. So that's what I'm trying to do here to see how accurate this is. What I want to show you as we look at this, so we're going to put that right. It's going to go up and down a little bit until it's right on the line. That should be pretty close. And you see these lines. That's what we're trying to add up. Now, here's what we're doing. We're just weighing a simple marker here. But as we look and we come in, we look and we say, okay, so that's 10, okay, so 1 is 11, but then we look at these lines, okay, so as we come in close, okay, there's 1 point, and then there's 10 lines, so each one's a line, so 1 point, there's a 5, okay, 6, 7, so this is 1.8. So when we look at this, we'll talk about this in a little bit on the board, but the significant figures here was 11.8. Well, we can't say it was 11.78 because it was just a little short of that line, because remember, as scientists, we can't put down anything we don't know. So this is where we go to what we call an analytical balance. Now, I want to tell you that in most high school labs, a lot of your college labs, these triple beam balances look really good, and they give you a good estimate of what the weight is. But I want to talk to you now about what we use. I want to talk to you what we use in a really in-depth research lab and in a college lab. We use what's called an analytical balance. So this is an analytical balance. I want you to see right away that it has all these different areas that we can open and close. We can actually turn this on, and we can actually make this airtight and take out all the air, and we can literally measure dust in there. Okay, so this is called an analytical balance. We want to look at our deal right here, and we see that it measures 3 decimal places. Okay, so see, it measures 3 and gives you exactly 3 decimal places. So once again, analytical balance, the triple beam balance. We also have electric balances. You see the little electrical balances, you put them on that measure them to 1 decimal place. Very inaccurate. Okay, so once again, let's just check and see how accurate this balance is. This balance said that it was 11.7. Okay, so let's see how accurate this one is. Okay, so now we're gonna take the same pen. We're gonna put it into the analytical balance. Okay, we're gonna put it into the analytical balance. We're gonna seal this. We're gonna seal this door. We're not going to take the time to suck all the air out. It's not quite as critical for this one. But the good thing about an analytical balance is it tears itself. T-A-R-E, brings it back to exactly 0 every time it's used. It also has a little bubble in here. We make sure it's perfectly level. The scale lets you know when there's a problem. So when we come in, we see the exact weight of that pen, okay, or the marker, was 11.271. And what we got, once again, we look over here, we got 10 and 1 and then 7 lines, so we had 11.7 is what we got there. So as you can see, there was a pretty big margin of error. So this is just a good indicator. The same with the little pen balances and the electronic balances and all the things that you see we use in high school, even a lot of times in basic freshman college labs, we'll use those. But when we go to research, I wanted you to see a true analytical balance. Once again, it's an expensive balance, but the accuracy is incredible. You're probably talking about probably talking about between $3,000 and $4,000 balance here. So really an expensive piece of equipment. Once again, the other feature on this one is that we can actually make this airtight and take out all the air and actually measure a speck of dust in there. So that's how incredible it is. So we're going to take this pin out, and let's take a real quick look at significant figures. Now, I wanted to show you this because what's happening with this balance, and the reason why this balance is so accurate, is this balance is adjusting for the amount of air that's in there also. So it's what they call tearing, and I keep saying that. The word is T-A-R-E. It's bringing that back to zero, so we know that balance, anything we put on there is the actual weight. So when we put this on, okay, then right away it's going to take a minute. It shows that it's adjusting, and once again it's going to automatically tear every time to where it's exactly back to zero. So even if we had dust on the plate, it would take account for that, move it back to zero before we put our object on the plate. So I wanted you to see an analytical balance. Once again, it opens. We can open it from front and back. If we want to put something in, we can open it from the top. We can seal it off. So I wanted you to see an analytical balance. Once again, super accurate, 3 decimal places. They also have an analytical balance that goes 4 decimal places and 5 decimal places, and the more decimal places it goes, the more valuable it is. So this is a 3 decimal place, really an important one. Let's look real quick at what we're talking about in terms of significant figures. So basically, when we looked at the triple beam balance, we've got a little glare on our board here. Let's see. Let's come over here. And apologize for all the other stuff on this board here, but I've got a little bit of a glare. So let's take a look at this. So the triple beam balance, okay, the triple beam said that was 11.7 grams, okay. Now, so how many significant figures? 1, okay. Now, when we looked at that, and we talked about this a little bit earlier in the class, okay. We looked at this a little bit earlier. So there's 10 lines, 1, 2, 3, 4, 1, 2, 3, 4, and then the 5th line comes down a little bit, 6, 7, 8, 9, 10. So even if our mark is right here, okay, even if our mark is right here, and we see that it's not quite, all you can tell in science is exactly what you have. So you have to measure it to the nearest mark. So if I blow that up, okay, and we're looking at these big lines, okay, and here's where the marker is, all right. So that's 0.1, 0.2, 0.3, 0.4. I can't look to myself and go, oh, that looks like it's about half, so I can't call that 0.25. I can only go 1 decimal place, and I have to say that it's 2 because I know it's 2, but I don't know how much it is into 3. Okay, so that's a really big thing. So once again, we took that, so you can see why 1 significant figure is all we can go. We don't know anymore. But when we did the triple beam balance, and I don't remember the exact deal, but it was about 11.26. We'll just say 264 grams. So you can see why we would say, okay, if I report that as 11.264 grams, then I actually measured that. The only way I can use 3 significant figures is to say, I measured this one at 11.264, and I measured this one at 11.7. But when I add them together, like let's say somebody reported a weight on a triple beam balance, and somebody reported a weight on an analytical balance, okay, and I want to add them up, okay, I get 22, all right, 0.964, but how many significant figures do I have to have? I have to come back to the least number because I have no idea what this was afterwards. Even though I know this, I have to go to 1 significant figure. So this is kind of a neat one because we're going to round it up. Okay, the 4 is less than 5, but the 6 is more than 5, which is going to round this one up. It's going to make it 10. So it's actually going to make that, it's kind of interesting, 23.0 is our scientific answer because we rounded that up and we could go 1 significant figure. Once again, the only reason we had to do that was because this triple beam balance only gave us 1 decimal place. Okay, so don't make it complicated. It's pretty easy. Had I measured both of these on the analytical balance, okay, then I would have been able to use all 3. I would have been able to use all 3 of these decimal points here. I would have been able to go to the tens, hundreds, and thousands place because I had actually measured them. So once again, just a quick lesson on an analytical balance. Another quick lesson on significant figures and scientific figures. And why in science it's so important. We can only report what we know. Analytical balance, triple beam balance. So Once again, we'll have some more discussion on what we call precision in science, but I wanted you to see an analytical balance.